we're going to take a look at transformation of functions. We're going to use points. These are great examples and explanations for SAT questions as well. Now, in your math classroom, you've probably seen some kind of form written like this, where some new function that we call g of x is equal to transformations of some old function, f of x, and there's different ways we can do it. We could multiply that function. Inside, we can affect the x values by multiplying it or add or subtract numbers, and at the end of it, we can also add or subtract. So what I'm going to do is I'm going to first make sure we understand function notation, and then we're going to look at what it is to transform the y values and what it is to transform the x values. And I have the x value starred because that's the one most people struggle with. But after this video, you should understand it quite well. And the fourth example, we're going to look at 3 examples putting everything all together. So you can skip down to that if you just want to know how to do it. So let's first consider the functional value f of 2 is equal to 3. Well, realize function notation is f of x equals y, so x equals 2 and y equals 3 is the point. On a graph, that just means on the x-axis we go right 2, on the y-axis we go up 3. 1, 2, 1, 2, 3, and there's our point. In a table, you might have x and f of x, and if you don't like f of x, you can cross it out and write, hey, that's really the y value, and we can say x is 2, y is 3. Earlier on in your math careers, you may have seen something called the rule machine, which is just like an input-output. Something goes in, there's a rule done, and something goes out. That's all functions is. So we have x equals 2, that would be our input here, and our output would be y equals 3, as 2 going in as a result. And we don't know what the rule is, and we're not really concerned with that. It could be squared minus 1, it could be add 1. It's irrelevant to us as long as we know the values. So our first type of transformation, if we change the output, we're making changes on y. And where you will see that is it'll multiply the outside or we'll add to the outside. So notice these are changes on the outside of f of x, which is the idea of changing the output. So we're changing what y equals. So from our examples, 2 comes in, a 3 comes out, and then we're making changes. So what we can do is we can just come up here to our new function that we have to find. G of x is equal to 1/2 f of x plus 4, and just say, okay, f of x is really the y value, and we know that f of x is 3. So this is just y equals 3. So we are going to straight up say that g of 2 goes in, and we'd have 1/2 times f of 2 plus 4, which means we're going to have 1/2, and f of 2 is really just 3, plus 4, we have 1.5 plus 4, so we have 5.5. So g of 2 is 5.5. Now, for those of you that want to understand this graphically, basically we are shrinking the y value by taking half of it, and then we're shifting it up 4, adding 4. So that's the y values. They're pretty simple. The x values, I'm going to break down to 3 different ways to look at this. The idea of adding or subtracting to the x, the idea of multiplying by x, and the idea of doing both. Really, we can look at the idea of f of anything. Whatever we do to the x, we're going to have a nice little strategy to take care of this. So again, we're going to look at the idea that we have f of 2 equals 3. So we know when 2 goes in, 3 is coming out. That's what we know. So that means if we want to find this new function, the idea of g of something, this is the new point we have to find. We don't know what x value we're using. It's the x value that's changing. What we know is that x minus 4, we want that to be 2 because we know what the output is going to be 3. We just need to know what goes here. So basically, we'll say x minus 4, if that equals 2, we know a 3 is coming out. So we just add 4 to both sides. So we get x equals 6. This means that for the g function, g of 6 will be equal to 3 because we'd have 6 minus 4 would give us f of 2, and we know f of 2 is going to give us a 3 as an output. So this will explain to many of you why a minus 4 on a graph really means go right 4 because of what we have to do to find that value. Very similar idea for f of 2x. So again, we're going to use the point f of 2 equals 3. We know what the answer is when 2 is inputted to the f machine. So we want this to equal 2. So we will just say we want 2x to equal 2, so x will equal 1. So if we plug in g of 1, that means we'll have f of 2 times 1, which is f of 2, which is equal to 3, meaning g of 1 is equal to 3. So we only needed half the x value to get there because the changes we made before. And this explains why multiplying by 2 really squeezes the graph. So it's a horizontal compression. And then if we put them both together, sometimes people get confused by order, but we're not going to worry because it's really the same strategy. We take what's inside and we want that to equal 2 because again, we know f of 2 is 3. That's our given point. It's going to equal 2. Now you could distribute to solve. It doesn't matter, but I'd like to look at this by dividing by 2 both sides. So now I'm left with x minus 5 equals 1. So that's my compression. And then I add 5 to both sides, and that's my shift right 5, so x equals 6. This means that if I plug in 6 to the g function, I will get 3 as my output. Okay? So now, let's put it all together. Here are our 3 examples. So we're given the point f of 12 equals 9. We want to find a point on g of x given this rule. So we're doing a lot of stuff here. The first thing I like to do is let's take care of this input value. And what we're going to do for that is say, okay, we know changes on x, we just take the 2x plus 1 and we set it equal to whatever that x value was, which is 12. So I could divide by 2, both sides. We have x plus 1 equals 6, and then I subtract 1. So we know our new x value is going to be 5. Now our y value, what we're going to do is we know that the y value was 9 for the input of 12. So we're just going to take the outside pieces, the negative 1/3 plus 5, and do negative 1/3 times our y value, which I'll fill in a moment, and add 5. Again, our y value was 9, so this is y equals 9. So we'll just simplify this. Negative 1/3 of 9 is negative 3 plus 5. So we get y equals 2. This means our new point from f of 12 equaling 9 on g would be g of 5 equals 2. Second example is kind of set up as a trick. It doesn't have g of x by itself, and we have this point negative 3, 5 on f of x, and we need the new coordinate. So the first thing we do is that I like to solve for g of x. So we're going to have to subtract this 8 over and divide by 2. So let's go ahead and do that. We're going to have 2 g of x equals, we're going to subtract the 8 first. So we're going to have f of x minus 2 minus 8 because we're going to subtract 8 from both sides. And now I'm going to divide both sides by 2. And remember, division is distributive. So we're going to do it to each piece. So now we have g of x by itself. So this divide by 2 is the same as multiplying by a half. And then 8 divided by 2 is 4, so we have minus 4. So now we can make the changes on that point. Let's go ahead and do that. So we know that the x minus 2 is our x value, so that has to equal negative 3 because we know the output. We add 2 to both sides and we get x equals negative 1. Now our output is being multiplied by a half and subtracting 4. So we're going to do half. Our output was 5 because that was our y value up here. Half of 5, and then we're going to subtract 4. So we get 2.5 minus 4. We end up with negative 1.5 as our new y value. So we now know that g of negative 1 is equal to negative 1.5 using those rules on f. Last example. This one just seems like it's not written in the right form. We have negative 2, 6 as the point. So we know f of negative 2 is equal to 6. And we're finding f of negative 2x plus 8. Now notice, for those of you that do transformations by shifts, that it's not in the proper form. It doesn't matter. We can just take negative 2x plus 8 and understand we just need to know what will give us negative 2 as the answer. So we just set it equal to negative 2. So we could subtract 8 from both sides. We have negative 2x equals negative 10. Divide by negative 2. And we have x equals 5. So that means this new point when x equals 5, we're still going to have y equals 6. We didn't make any changes on the y value. So the new point is 5, 6. Now, that should take care of everything for you, but realize that everything we did with point applies to the next thing that you need to consider, which is transformations on base graphs, or the parent functions. So you'll notice on each of these graphs, y equals x, y equals absolute value of x, y equals x squared, y equals x cubed, y equals square root of x, y equals the cube root of x, and some random function. We can just focus on the point and know how to shift it. So